Before starting with the analysis, let's take a look at the background of these competitions. The Makridakis competitions are a series of competitions organized by the teams led by forecasting researcher Spyros Makridakis, and the main intention behind these competitions were to evaluate and compare the accuracy of different forecasting methods. Till date, three competitions have taken place in 1982, 1993, and 2000 respectively. For this project, I have been provided with a sample of 303 series out of the 3003 series from the third competition, which happened in 2000. The name of the competition was M3 competition. So the time series included yearly, quarterly, and monthly time series. For in each particular time series, it had the data for 101 time series, and the time series are in the following domains: microeconomic sector, industry sector, macro sector, finance sector, and demographic data. The 303 series of the M3 competition are distributed as follows. So in the table you can see that maximum number of time series are from the demographic data. Now we come on to the procedure for the analysis. So basically 7 steps were taken. While going through each step, I'm going to show you the R code, how the things are happening. So as you can see, the step one is like the data distribution. So the data is distributed into training set and the test set for each particular type of series. So here's the code for that. So basically 6 lists are created, and 3 for the training set and 3 for the test set for each type of series. Then a loop is created to extract the 95% of the data and put it into the training set and the remaining 5% into the test set. The, the logic for the loop is same for each type of series. After this, series before entering the automated system goes through the ADF test to check stationarity, and applicable Boxer transformation takes place if required after the test. That is, if the p value, you can see into the code. So yeah, so here is the code for that. So first of all, the ADF test takes place, and if the p value of coming out of the ADF test is greater than 0.05, showing the known stationarity, the applicable box cost transformation takes place, and the series which is returned is the transformed one. And if the p value is less than 0.05, we proceed with the original series. Once the transformation takes place, each type of series enter the system wherein all the possible combinations of state space models and the Holtz methods are considered. So the code has been created wherein the models without trend and models with trend are formed, and all the combinations are created. Then each series enter the system. This is the main system which takes all the series and creates the list of all the models for each type of series. So first of all, it enters this model with trend type of a function in which the ETS state space model happens. Then if there is an error, like for the forbidden combination, which is the main problem of the ETS model, we cannot get the what is the forbidden combination. So if there is an error, the loop doesn't stops, and it gets back to the next loop, and hence the loop doesn't stop. So similarly, this happens for all the ETS combinations. And then coming on to the hold one, it also takes like, I've put the try function in this so that any error occurs, it doesn't affect the loop for the model fitting or the forbidden combinations. Since this was the annual for the annual series, we can see that the stage force models are without seasonality, because we can neglect the seasonality factor for the annual time series. Once, okay, so once the everything is done, so the maze values for each applicable model for each series is calculated along with the Chumpak test and the Shapiro-Wilk test p values, and the model with the minimum base value is selected for each series. If you look through the code, this is the main code in which the test is performed. This is the Chombat text. and this is the Chyprotex test for the normality testing. And all the values are inserted into a data frame called annual series parameter. And once everything is done, the main the data frame is sorted on the basis of May's value in the increasing order of the May's value, so that we can get the minimum May's for each particular model. At last, after this, the best model on the basis of May's is selected, and now all the best model for each series are put together in a table along with the desired measures like MASE values and the P values for both the tests, and finally the mean MACE value for each type of series is calculated. So this is the series final result for each particular series for annual type of data. The best model is calculated with the minimum MACE values and the autocorrelation test values and the normality test values. Once it is done, the mean value for the maze and the number of count of as per the rules is calculated. After this step, we come on to the forecasting step. Once the best model is calculated, and so we get the okay, we do the forecasting of all the series on the basis of the data present in the test. And one more thing, there's a catch in this, like for all the transformed series, I created a vector at the start of the model when it before getting into the system. I created a an dot hold, which basically what is it doing? It's getting the series which are going through the box cross transformation, and lm dot here is a vector which is kind of uh, keeping the values of the lambda for that particular series which is going under the transformation. So once everything is done, the transformed forecasts are converted back to the original form using this formula. And at last, the final step is the forecasted values are compared with the actual ones, and MAPE is calculated for each series, which further gives the mean MAPE value for each type series. So this is basically the MAPE values, and this code gives the final MAPE values. So if I show you annual series MAPE is this one. So for each particular series, the MAPE is given, and at last, the mean MAPE is calculated. Now, the system is consisting of these 7 steps, but the difference lies between the annual series or the yearly series and the monthly and the quarterly series. Because the difference just lies that in the quarterly and monthly series, I have also considered the Holt-Winters method along with the state space model and the Holt, because there can be seasonality. We cannot ignore that factor. So the everything remains constant, just two more addition of Holt-Winters method gets into the system, and everything runs accordingly. Once every step is calculated for each type of series, we get with the final data. The conclusion comes out to be that for the yearly series, the mean MACE values comes out to be 0.718 and with a mean MAPE of 11.29%. In terms of quarterly, the mean MACE values for all series comes out to be 0.368 with a minimum MAPE of 9.38, and similarly for monthly, mean MACE is equal to 0.334 and mean MAPE is equal to 12.93%. Also, the conclusion what can be drawn from this project is that for yearly, quarterly and monthly time series, it can be seen that the trend the model with the damp trend is on the topmost, which accounts for the maximum number of models. Like in yearly time series, overall 9 methods were used to get the forecast values of the 101 series, out of which state space model with additive error, additive damped trend, and no seasonality account for 24% of the total series. Also, one main conclusion which we can say after doing this project, and also which the researcher found, was that the statistically sophisticated or complex methods do not necessarily provide more accurate forecast than the simpler one. So that's it. Thank you so much. And the references for this project were from the Wikipedia and from the Stack Overflow. Thank you.